Good morning, colleagues. Um, this is the advanced object-oriented programming. We're going to start looking at this. I would want you to pay attention and see how best you grasp the concept. So, advanced OOP is basically we are building on the previous uh, course on introduction to object-oriented programming, where we know that this is a programming concept that represent everything in form of an object. So once you understand that with object-oriented programming, everything is regarded as an object, that becomes much easier for you to understand this programming language. So when you talk about object, we know that object has states and behavior. And once you know all that, then even coming to talk about this advanced OOP, it becomes very easier for you to understand. So with that said, in this course, we are going to look at inheritance. Okay, we'll look at inheritance. And in this, we'll look at the inheritance, we'll look at the definition of inheritance, the benefit, a single inheritance. Of course, we'll look at the types of inheritance. Then we'll also go further to look at the benefit of inheritance. Then also look at the member access rules, the aspect of superclass or superclasses. Then we also are going to look at the polymorphism, which is also an aspect of a feature rather of object-oriented programming. Then we'll look at the method overriding, which is also another feature of object-oriented programming. Then we will see using the final with the inheritance. Final is actually a keyword in Java. So we're going to see how we can use it with the inheritance. Then we'll also look at the abstract classes, okay, as well as base class objects. Base class objects, this is another thing that that we are going to look at. Okay. Okay. Quickly, let's go into a definition of inheritance. So inheritance is the process of acquiring the properties by the subclass, okay, derived from a child class or derived from a superclass rather. Okay, so in short, we are saying inheritance is a process of acquiring the properties by the subclass from the superclass. In this case, you have a class which is a parent class or a superclass which has got a certain features, and now these features are declared, okay, in the parent class. Now, should we want to use the same features in another class or a child class that we create, then what will have to be done is that we'll have to use we have to inherit, the child class has to inherit these features from the parent class. We don't need to recreate these features, but all we need to do is inherit them. And for us to do that, we are saying a child class, which is defined as an abstraction, inherits its parent class. Okay, so it inherits through the use of a keyword extends. Okay, so it inherits all the properties and method of a parent class. Okay, and these becomes members of a child class. So when the child class inherit all this becomes the um, this becomes the properties of a child class. So in addition, a child class, of course, can add its own new data fields or properties. So in short, what we are saying is that uh, beside the beside the child property, the child class inheriting the fields or the properties and methods from a parent class, it can also have its own properties. Okay, it can also have its own properties. So it can override the method that are inherited from its parent class. So this is the syntax. The syntax, the keyword extend is used to define inheritance in Java. Okay, the keyword extend is used to define inheritance in Java. So this is the syntax. This is the syntax. We say class name. This is the name of a class, a subclass. Okay. Now we use the word extends. Okay. Extends, then superclass name or parent class name. Then you begin and end, and then the rest is the body of the class. So this is the syntax that you have. So you have the child class or any other subclass that you have, and this subclass has to extend. Okay, has to extend superclass or the parent class. So this is what is inheritance. Okay, so now this is single inheritance. We have derivation of a class from only one base class or only one parent class. This is called a single class. Okay, this is called a single class. In short, here we have class A, which has got some members. We are saying members of class A. Then we derive a class here, a subclass. So create another class called B. We say class B extends A. Okay, class B extends A. Okay, meaning class B inherits the properties and behavior of class B. It inherits the properties and behavior of class A. So in short, we can say B to A. So meaning B inherits the features of A. Okay, so this is an example we have. This is a practical example where we have class A. In class A, we have defined the variables int I and j, okay, which are properties. Then we have one method called the show I and j. And there in this method, we are want to print the value of I and j. Then we create a subclass of A, which is subclass B, extends A. Then, of course, B, like we said, this aspect of extends, it's the inheritance part. Okay, it's the inheritance part. So this one, of course, we are saying B inherits all these that are in A. But despite it inheriting all these, it also has its own properties. Okay, it also has its own properties, such as K and D. It also has B. It also has a method there. It has two methods here. Okay, then this is class simple inheritance. Of course, this is just to try and test this uh, these these variables. So we'll try and run this. Um, let's run Eclipse and see. So okay, that's what we are saying. So if you look at the you look at this, you'll find that we have we are creating an object of a class A, which is called the super up, and then create another object of class B, and then we call the variables I and j, and assign them a value of 10 and 20 respectively. And then we want to print this statement. That's after calling the super.object is show I and j. You find that this is a method that is coming from the super class. Okay, the super class A. Okay, then there, of course, we also have these members. Sub-object 1, we assign I, we assigned it to 7. Sub-object J, we assigned it to 8. Sub-object K, we assigned it to, and then so to show IJ, and the sub IJ, of course, this is coming from the super class. That's the method in super class. And the show K, this is the method coming from, and then print. Okay, we have the sum. You'd see to it that this is coming from the sum as well. Okay, so I'm going to stop sharing this, and then I share the other screen. Okay, that's okay. I'm going to I'll just create an object inheritance. I'll create a project, Java project, advanced OOP. Then I come new class, say class A. This is advanced OOP. Okay, there we Then I'll just create class B. Class B extends class B extends A, begin, end, like that. Then we are there, we say int, okay, int I and j, I and j there. Then we say void show as a method. Okay, we end. Okay, there we're saying sys out I and j, sys out I and j, I and j. Okay, just to be okay, plus that's a concatenation I j. Okay, I then plus j plus j. There we are. Then we come here, we say int. Here we created the method called k, sorry, a variable called k, and then we are going to show k. Int k, int k, okay, int k says sys out, okay, say k plus k, then that is there again, void sum, begin sop I plus j, sys out I plus j plus. Now take note of this. We have our I is in class A, then our j is in class class A as well. But K is in class B, which is a subclass of class A. So now, here what we are trying to do is, you can see this method sum is in class B. But despite that, we are making use of the properties which are I and K, I and J, which are defined in class A. The reason why we are able to do this is because of the inheritance aspect, which is the extends aspect here that we've put there. That is the reason why we are able to extend. Okay, so we'll do this. Okay, so just plus Okay, that's K. That is K. So say in bracket K in bracket, what you're saying, we are saying plus C plus C I plus J plus C plus C plus K. Okay, I plus J plus C plus K. That is the that is what we have. So okay, we come here. We come here. We say class simple inheritance. Class simple inheritance. Begin. Okay, thank you, local variable. Okay, so here you see why it's showing this, flagging this as errors, because I removed the word extend. Okay, so saying class simple inheritance, public static void main, public static void main string args okay, string args for argument okay, we can just do this, get this, get there, args, and then we put this there, and then say begin, and okay, there we are, and then we start to create an object of a class. We say class A object object of that class A. Then you, so meaning just say super object. So meaning this is an object from a super class. Then this is equal to new A. Then you begin and close there. Then B, we say sub object is equal to new B. Okay, we close there. I'll keep saving my work. So we're saying now sub, okay, we start with the super for objects dot I sorry dot super object dot I. This one initialize it to 10. Then we say sub object, okay, sub object dot j. dot j. This one initialize to 20. But now now look at something here. We're saying this is the super class, the object of a super class, okay, where our I is initialized to 10. Okay, now we are calling the j in a subclass, but did we define any j in this subclass? Okay, have we defined any j in this subclass? No, but despite that, we are calling this from the superclass through the word extends. Okay, so I'm just going to write this sysout. Okay, sysout, what do you want to write? You are saying content of a super object, content of the super object. Okay, that's the content of the super object. Okay, so then I call the method. I call the method now through the use of super object dot show. So I want to call this method that is in super class. So what I'm going to do is I'll just say super object dot, okay, show I and j. So that's the method, as you can see, that's the method that is in a super class, but I'm calling it here so that we see the content. Okay, then I'm going to define to initialize the values to these 3 variables that we created in super classes. So I'll just sysout to avoid so what we have sysout okay. Now I want to use now the objects created in a subclass. Okay, so remember we created this. There are these 3 objects. The objects, of course, you have 3 properties that you want to assign values. So just say object dot I, object dot I, and this one I initialize it to 7. Then I say object dot j. This one I initialize it to 8. Then I say object dot k, and this one I initialize it to 9. That is it. We've initialized the values now. Of course, you've seen that these variables were created in super class. Okay, but now this one that we are trying to initialize, this is to take effect in the subclass. But we are trying just to ensure to teach you to say with inheritance you can use and declare variables that are already in a superclass, but you can make use of them and assign them new values in a subclass. Okay, so I'm going to say sysout content of a subclass. Okay, so now here now I'm going to start calling the methods that are in there. I'm going to start calling the method now that are in a subclass. But of course, one point you need to keep in mind is that this method consists of values and variables that are available in superclass, but simply because we are inheriting them, we can call them in our subclass and use them without any problem. Okay, so this is what we are going to do. So I'm going to call the first method. Okay, I'll start by calling the first method that is in I'll start by calling the sub method. Okay, the superclass method. Okay, in a subclass. So I'll just say sub object dot show I and j. Okay, so I'll comment that to say a method in a super class. Okay, then again sub object dot show. I start calling now the method that is in the subclass, so which is show k. Okay, the method that is in subclass, which is show method supposed to be show k. Okay, so I'm calling it now. Just say show sub object dot show k. It comes there. Okay, then we print line sysout. Okay, and then we call the other method, which is now the sum, which is now the sum. Okay, sysout. First I will print a statement to show that I'm getting the sum of I, j, and k in the sub object. Okay, the sub object. So I'll read this as the sum of show the sum of I, j, and k in a subclass method. Okay, in a subclass method. Okay, then when I come here, I just now call that sum method. So I just say sub object dot sum. Okay, this is the sum. Voila, here we go. So now I'll save this and then run my code. Okay, when I run my code, you're uh, supposed to see this content, supposed to see this content here. Just go on configuration, run configuration. Okay, example while loops. So this one is um hello class. Okay, so run this class, show command line, then I say okay, run. Why is it showing this? Okay, so in that case, what I'll do is I'll just separate these two. I'll, I'll cut that and then just come in this create a new class, create a new class. That is the name of the class will be simple inheritance. Simple inheritance. Okay, so that's the name of the class. So put it there. Okay, so now when we save this and run, still giving us error that the main method not found in a class. In a class A public static void main string. Okay, let me just okay. Okay. So when you run this, it should be able to give you the results. Okay. Okay. Okay, so I should try and run this code and then be able to see um, these results. Okay, should be able to see these results. Okay, so when you run the codes, like I said, you should be able to see the result that I've highlighted here. Okay, should be able to see those results. Please ensure that you run the code and see those results. If you don't see them, then verify your code. Okay, verify your code and ensure that there are no errors. Okay, so these are benefits of inheritance, software reusability among projects. So we're saying codes can be reused among many projects. Once you've created them once, then you can make use of them severally. Then the code to insert a new element into a table can be written once and reused. So that's what we are talking about. Code reusability is one benefit of inheritance. Then there's an aspect of code sharing within a project. We are saying it occurs when two or more classes inherit from a single parent class. Okay, so these can be able to share the same code from the superclass or the parent class. So this code needs to be written only once and will contribute only once to the size of the resulting program. Then increased reliability. Of course, this results from the reuse and the sharing of code. Okay, that's still the benefits. Then it also provides what we call information hiding. Okay, so the programmer who reuses a software component need only to understand the nature of the component and its interface. Okay, so it is not necessary for the programmer to have detailed information such as the techniques used to implement and so on. So what it does is basically just reuse the software that has been done before, and then um, the details of the programmer who did that work is kept hidden. So rapid prototyping through code reusability, through inheritance, you can come up with a prototype quite easily and quite quickly. Okay, so quickly you can assemble from pre-existing component and then uh, um, come up with a prototype. It is consistent also of interface among related objects since you are using the same aspect of the code. So you are going to achieve that aspect of consistency. Okay, so inheritance also enables programmers to construct reusable components. Okay, reusable component, so that can be another aspect um, of inheritance that we need to understand. Sure. So now, polymorphism and the framework. Okay. So high level reusable component, we are talking about the code reuse, which decreases as one moves up the level of abstractions. So the lowest level routine may be used in several different projects, but the higher level routines are tied up to a particular application. Okay, so I'm talking about the polymorphism where you can use one application, one code in different forms. Okay, so polymorphism in programming language permit a programmer to generate high level reusable component that can be tailored to fit different applications. Okay, so these are types of inheritance that we have. We have single inheritance where we have just one single parent class and also a subclass like we had in our example where a subclass inherit features of a parent class. Then we have multiple inheritance where you have class C inheriting the features of class B, okay, which has also inherited the features from class A as a parent class. Okay, that is under multiple inheritance. Then we also have what we call hierarchical inheritance, okay, where we have the three classes or the classes directly inheriting the features from the parent class, but not from their fellow classes. Okay. Then multiple inheritance. We have a situation where we have a single class such as C inheriting the features both from class A as well as class B. Okay, so this is the types of inheritance, and we have this example here for single inheritance. Okay, we are saying class A, we've created the class called A. Okay, now this class, we also have another class B which extends class A, which inherits properties and behaviors of class A. That is single inheritance. Hierarchical inheritance, you have class A, then you have class B that extends class A, then you have class C also extends class A. This is hierarchy from hierarchical kind of inheritance. Multi-level inheritance, we have class A, okay, class A here, which is the super class. Then you have class B, which extends class A, and then you have class C, which extends class B. That is multiple inheritance, multiple level inheritance. B extends A, then C extends B. Then you have multiple inheritance. Okay, this one now uses the aspect of interface. Okay, and now when you are dealing with interface, you don't use the word extend, but you use the word implement. Okay, so we are saying interface 1, interface 2. Okay, so now here we are saying class A implement 1 and 2. So meaning it has taken into consideration the features of A, okay, of 1 and 2. Okay, so multiple inheritance, you implement it, use implement, okay, because then now instead of implementing classes, like extending classes, you use interfaces. Okay, so class B extend A, implement C and D. That is okay because you are talking about multiple inheritance. Class B extend A, meaning class B is a subclass of A, and then implement. Okay, it implements C and D. So this C and D are subclass to B. Okay, that is okay, but you can't say class B or class A, class C extends A, extends B, or class C extends A, B. That is wrong. Okay, that is wrong, syntactically wrong. Okay, a superclass variable can reference a subclass object. Okay, a superclass variable can reference a subclass object. Um, when a reference to a subclass is assigned to a superclass variable, you will have access only to those part of the object defined by the superclass. That's what you are saying here. Okay, it's an aspect of a superclass variable being referenced in a subclass object. Okay, so we have class A here. In class A, we have one variable which is I, and this value is initialized to 10, as we can see. Then you have class B, which extend A. And here we have a variable called J, and this J is initialized to 30. Now, here's the tricky part. We create for both class A and class B. And now what we are doing is referencing uh, class referencing the objects of class A to that of class B, class B object. Okay, then you just call this by saying system.out.println. We call now this one the I, which is defined in class A. We are now calling it in the object here, in object B. In fact, if you want, you can still even just say B dot I. So that will still call the same variable, because we have done we've called it through referencing. The super keywords. So subclass refers to its immediate superclass by using the super keyword. Okay. This is how a subclass make reference to its superclass. Okay. It uses the super keyword. It uses the super keyword. That's how the subclass makes a reference to its immediate. That's the key point to understand. Its immediate superclass. Okay, through the use of keyword. So the super has two general forms. The super has two general forms. First, it calls the subclass constructor. A constructor is basically we saw that in OOP. Second, it is used to access a member of the superclass that has been hidden by a member of a. Okay. Now, using a super to call a subclass constructor. Of course, here you can make use of the parameters if there are parameter lists here. So parameter basically specifies any parameters needed by the constructor in the subclass. Okay. Any of these in a class. So the super must always be the first statement executed inside a subclass constructor. Okay. So this example, we have class B, class box, okay, which is a subclass. Here we create a method called box, and we print this statement box in a superclass. Okay, then we have another. This is a constructor with one parameter. Okay, and the statement being printed in there. Then we say class box word. Okay, extend box. So this is a superclass. This is a subclass rather, making reference to the subclass. And then we have box word, it's a method, and then we print that. Then we have the class demo box, public. Yes. Hello.
Yes, yes, sir.
Coming. Yes, sir.
So, how possible does it work?
It's gone for a meeting.
It is you leave the cookies are supposed to put the cookies, say you leave the information is correct.
Yes, sir.
So true.
So as class demo word, then public static void main string hugs and so on. Then box word, my box is equal to new box. That's the method that has been created. And the output is as follows: box in superclass, then box word in a subclass. Okay, then you have class box here that's using super to call super class constructor. Of course, we are using the same text here to ensure that we make use of the super keyword. So here what we are just doing is that the code remains the same except here where we just use the word super and you pass in the parameter item. So the second form of super acts somewhat like this, except that it always refers to the superclass of the subclass in which it is used. So super.member, okay, that's the syntax, super.member. And then here the member can either be a method or an instance variable. That is a member. So this second form of a super is most applicable to situation in which members name of a subclass hide members by the same name in the super class. Okay, so it's using superclass to overcome what we are calling name hiding. So we have class A there with one variable called I. Then we have class B which extend class A, and you have int I, again another variable or same variable name created in a subclass. So this is what we are saying. This is now the one that is going to hide the I in superclass A. Okay, then we have B, which is a constructor. We have a B constructor which has two parameters, A and B, all of data type integer. Okay, so get to assign the value of I to A and I to B as well. And then we have that method, okay, that method which is in class B, and then we use the superclass to test and get the result. Okay, so that is it there. Those are the results. Those are the results. When you run this program, you should be able to get result. I in superclass is 1. I in superclass, in subclass is 2. Okay. Now let's understand when constructors are called. We are saying in a class hierarchy, constructors are called in order of derivation from the superclass to subclass. Okay, so super must be the first statement executed in a subclass constructor. Okay, so the super must be the first statement. So if super is not used, then the default constructor of each superclass will be executed. Implicitly, default form of a super will be invoked in each subclass to call default constructor of a superclass. Okay, so this is an example. Class A, we have a method for class A, and there we are printing inside A's constructor. Then class B, of course, that's a constructor rather. Class B extends A. So that's B constructor, of course, without parameters. So we are printing inside B's constructor. Then class C, B, we are saying class C extends B, and then get the constructor of class C. We are saying system.out.println inside C's constructor. Then in class calling cons, when you call this method, you find that this will be the output. Okay, member access rules. Member access rules. Member access rules. So a subclass includes all of the members. Okay, the access rules, we are talking about the default, public, protected, and so on of each superclass except the private member. Okay. A subclass includes all of the members. We are talking about the default public protected except for private. So meaning it makes use of all these members of a superclass that belongs to a superclass except for the private. So meaning the default, the public, protected and so forth can still be accessed. Okay, it can still be accessed.
the requirements stage, when you are looking at the specification. So from this now we have the state guidelines.
Any question on this one? Is it clear? Before we look at the second scenario. Okay. Thank you. Let's look at this other scenario. Okay, study 2, data analysis exercise. Okay, if you read this, we are saying the company is organized into departments. Each department has a name, number, and an employee who manages the department. We keep track of the start, the department, we keep track of the start date if the department, of the department manager. Okay, so a department may have several locations. Each department controls a number of projects. Okay. Okay. Each department controls a number of projects. Okay, so each project has a name, number, and is located at a single location. So we store each employee's social security number, address, salary, sex, and birth date. Okay. So each employee works for one department, but may work on several projects. Okay. So we keep track of the number of hours per week that an employee currently works on each project. We also keep track of the direct supervisor of each employee. So each employee may have a number of dependents. For example, for each dependent, we keep their name, company, set, birth date, and relationship to the employee. Okay, so just from your own understanding, uh, uh, what are the possible attributes from this work, from this scenario, from this case study? What are the possible attributes?
I think from this company as organization, so departments is an entity. Then attribute name is an attribute, number, and an employee. So the attributes.
Okay, so which ones have you picked?
I've picked attributes as name, number, and employee who manages the department. So it could be employee
as attributes, okay, or as entities.
Yeah, as attributes, name, number, and employee. Maybe this employee is an ID.
Okay, employee number. Okay, What? That's Mr. Andrew. What about the others?
So for employee, this can be name, um, this is social security number, address, salary, sex, and birthday
Okay.
attributes for employee.
Okay, that's attributes for employees. Okay. Um, what about others? You're quiet.
Every class, every description of the class will always have a class name. Next, it will always have an attribute, and it will always have an operation. So these are the three key elements of a class that describe.
So I can say also maybe project as an entity.
Okay.
Then the attributes of the projects, we have the project name, the number,
Okay.
and maybe location. Yes, sir.
Project name, the number, and the location.
Yes, sir.
Okay. Okay, that's fine. Okay. So let's see what we have here. Okay, here we are. This is the entity relation diagram. Okay, this is the entity relationship diagram. So we have the employees. Those of you who said employees, that is it. Okay, that's for employees. Okay. Sorry. Okay, so that is the employees. Employee has these attributes: social security number, birth date, salary, address, and so on. And then we have the name, which is a composite attribute because it has other attributes. Okay. Then you have departments. Department has an attribute, as an entity also. Then project as an entity, and then dependent. So now all these have got attributes associated with them, and we have the relationship there. Okay, so I'm saying employee can supervise, is a supervisor, can supervise one or more employees, other employees. Then the dependent, a dependent can have one employee, of course, can have one or more dependent. And now each of these dependents have the attributes associated with them in terms of the attribute name, gender, and the birth date, as well as the relationship. Okay, then we are saying employee can work from more than one department. Okay, so this is a work attribute. Then weak attribute, we are saying a department can have a number of employees associated with it, and a department can be managed. An employee can manage one department. Then there's a control. A department or a single department can control one or more projects, and each of these projects can have the name, number, and location. So this is the entity relationship diagram of that particular scenario we are been talking about, or the case study. The case study. Okay, that's the case study. Okay, is it clear? Just take a close look at it, analyze it, and let me know if it is somewhere where you need clarification. We'll debate it and ensure that you understand.
We show it in the case. The set of characters we design in the system. So it's too passive, it's not really showing the details very well. You don't see the associations.
Okay, is that clear? Then we proceed. So in the diagram above, we have three basic entity types, which are rectangle shaped, okay, which are rectangle shaped, and one weak entity, okay, typed rectangle shape with a dot, with a double line border. That's a weak entity, okay, like this one here is a weak entity. Yeah. So the three basic entity types are employee, projects, and the department. Okay, so those are the three entities. Few attributes are listed for each entity. One attribute from each entity is identified as the primary key, and this is underlined. So whenever you see the underlined aspect like this, you should know that is a primary key. In this case, this is the number. Okay, and here we have here it's a composite key because you have two identifying a project. We have the number and the name, and under the department there's a number and the name and the number. Okay, so here, yeah, so those are the that's the primary key. Okay, so there are composite attributes such as the name of an employee, multi-value attributes such as the location of the department, the oval with a double line border, that's a multi-level. So attribute number of employee is a derived attribute. This means that we do not store it as a value, but it is stored as an operation which is calculated at runtime. Okay, so there are four binary relationships and one unary relationships. The relationship works for specifies that a department must have some employees working for it, and an employee must work for one department only. An employee must work for one department. Okay, that is works for. Okay, of course, we're talking about the aspect of, if you look at this, this is a many. We're saying employee can work for at least one or more departments. Okay, that's how it is depicted there. So there are four. Okay, that's we've talked about. Then, while the manager's relationship indicate a department must be managed by one employee, only one or only, and an employee may or may not manage a department. So we may record the starting date of such a role in the attribute relationship start date. Okay, so that's some of the thing you may need to understand. So uh, the relationship works on indicate that a project must have many employees working on it, and each employee must work at least in one project. Okay, for each employee, we keep the working hours spent on a specific project in a relationship attribute. Okay, so the supervisor or the supervision relationship is a unary relationship indicating that an employee may or may not supervise many employees, and an employee may or may not be supervised by another employee. Very important. An employee may be supervised by another or may not. So the entity dependent is a weak entity type. A weak entity is an entity type that does not have a key attribute. That is an entity type. So dependent is an entity type because it does not have it does not have a key attribute. So a weak entity type must participate in an identifying relationship type with an owner or identifying entity type. So entity types are identified by a combination of a partial key of the weak entity type, okay, as part of the identification. Then the particular entity they are the particular entity they are related to in the identifying entity type. So dependent is identified by the dependent's first name, date of birth, and specific employee that the dependent is related to. So those are identifiers of the dependent. So employee is its identifying entity type via the identifying relationship type dependent of. Okay, so in the exam you may be given such a diagram and then you be required to explain it, to provide a comprehensive explanation of this entity diagram. Okay, I think this marks the end of this unit. Unity 5. Unity 5 ends here. Any concern? Any addition?
Just from the diagram, sir.
Yes, sir.
Yes. So you said, just clarity. So M is menu, right?
Yes.
And what is that? Okay. And N is what?
Multiple. In short, these are used interchangeably. So, yeah, in short, these are used interchangeably. So this is many to many, many to many, or some books they can use N to N. But to differentiate that, you are just using M and N.
Okay. So
But
which
when you
means
see
many
them,
to many.
yeah, when you see that, you should actually know that it is signifying many-to-many relationship.
Okay.
Yes.
So in the situation of department and employee, dependent and employees, so that means that is many to one relationship. Right?
Yes.
We could have M or N.
Yes.
Okay. Understood.
All right.
Thank you.
Thank you.
Let's move back to Unit 1 design. We've looked at how we can design the system and program design all those rules and process the system design. So what happens with the program?
We have another lecture this week.
This way for database?
Yes.
No.
Or is this the last one?
But you are supposed to have at least one. Because that's why the trouble is for you on distance, you always lag behind. Yeah. So
But you give us the same exams.
only yes, because it's more like probably that's the reason why you pay less, because there's some aspect of self-study involved. Yeah. So here I think we just need to do one. We just need to do we just need to do okay. In fact, get this one as self-study. Take this as self-study. Then it will take you straight to, of course, that is unit 5 as self-study. Then it will take you to unit which one? 7, which is okay, unit 8, which is the relational database system. This is where your colleagues are on full time, and that is where we ended. And that one was made as a self-study. Unit 6. You get the point? So find time to look at relational databases, where we focus our attention on the structured query language. Okay. And we'll start from here. Meanwhile, this one will not be covered. The others are just self-study. Okay. So end of unit 6. So unit 6 is self-study. Then we'll come and start from. It's clear you read and understand, but should you have any issue, you can let me know. We can always make time, and if it means us having a class to discuss that, you can do that. Okay, with that said, I think this marks the end of today's lecture. Let's see when we can at least have another class, our last class.
There's a class on Sunday.
Or there's a class on what time?
10:30.
10:30 hapa Sunday ni non-start. Toa kutambia kuchechi mashoka. Hapa Sunday ile Einstein non-start. Toa kutambia kuchechi.
More yote.
Kwa hiyo kwa mchongesha kwa register. Stand.
Yeah, no. It's important.
We can have it. Do you have class tomorrow in the morning? Maybe the same time, 10 hours.
No, this is the last week. We're not having any classes next week.
No, I mean